Bitcoin is often described as unhackable, secured by mathematics, not trust. No government controls it. No bank can freeze it. No hacker can crack it. At least that's the pitch. And that's the whole thesis for a lot of people holding crypto right now.
There's a serious conversation happening among cryptographers and engineers, the people who actually build this stuff, about a moment where that assumption may no longer hold.
Q-Day.
Q-Day. And once you understand what Q-Day actually is, you're going to want to know exactly where your Bitcoin stands when it arrives. Q-Day is the point at which a quantum computer becomes powerful enough to break the cryptography that protects Bitcoin, and frankly, most of the digital world.
And we want to be crystal clear. This isn't some bug in Bitcoin's code. Nobody left the back door open. This is actually about a new kind of computing that will make the math underneath Bitcoin security solvable in a way that it just isn't today.
Very simply, classical computers, every laptop, every phone, every server, work with bits. A bit is either a 0 or a 1. That's the foundation of everything digital.
Quantum computers, on the other hand, work differently. Their basic unit is called a qubit, and a qubit can be in multiple states at the same time. And that's not a metaphor. That's a physical property of quantum mechanics.
What that means practically is for certain kinds of math problems, specifically the kind that Bitcoin security is built on, a quantum computer doesn't have to try every possible answer one at a time. It can explore many possibilities simultaneously.
And that's the threat. Not that someone writes clever code, it's that the problem Bitcoin thought was unsolvable becomes solvable.
So here's how Bitcoin security actually works. When you own Bitcoin, you have two things, a public key and a private key. Your public key is like your address. Anyone can see it. Your private key is the password that proves that you are the owner.
And the security assumption is this. Even if someone knows your public key, it's essentially impossible. When I say impossible, I mean computationally infeasible, which is a technical term, to reverse engineer your private key from it. With classical computers, that's true. You could have every computer on Earth working on it for longer than the age of the entire universe, and you still wouldn't crack it.
But then we have quantum computers running something called Shor's algorithm that changes that equation dramatically. It can solve the specific type of math that stands between a public key and a private key. Now, not instantly. I don't want anybody freaking out. Not instantly, not today, but in principle and with hardware that researchers are actively building toward.
So the threat isn't that someone steals your password, right? Don't go moving your private keys to a different space unless you got them in your kitchen drawer. The threat is that someone derives your password from information that's already publicly visible on the blockchain.
And here's a detail that matters for Bitcoin holders specifically. Not all wallets are equally at risk. If you ever sent Bitcoin from a wallet address, your public key has been exposed. That means it's on the blockchain forever.
Forever. On the other hand, wallets that have never sent a transaction only expose a hash of the public key, which is harder to crack even with quantum. But any address that's already sent funds, the full public key is already out there.
So let's answer the question everyone is actually asking. Vin, is Bitcoin dead?
Luckily, the short answer is no, at least not today, right? The quantum computers that exist right now, even the most advanced ones from IBM and Google, are nowhere near capable of doing this, okay? We're talking about systems that would need millions of stable, error-corrected quantum bits. Current machines have hundreds to a few thousands, and most of those are noisy and unreliable.
So we're not in the danger zone yet. But here's the problem with that answer.
Most people think about the technical progress in a way that they think about walking, linear and predictable. 30 steps gets you 30 meters across the room. That's linear thinking. But quantum computing doesn't work like that. It works like doubling or exponential, right? Compounding. 1 step, 2 steps, 4 steps, 8. 30 exponential steps, you've actually circled the Earth 26 times. Our brains aren't designed to think in exponential terms. And that goes back to if you ask someone, hey, how far would you get if you took 30 exponential steps versus 30 normal steps? People probably would say, oh, a couple miles at most. Or it's the same thing as you asking someone, would you rather have a penny doubled every day for a month or $1 million? Most people pick the $1 million because we think linear.
Exactly. And some researchers say Q-Day is 10 to 15 years away. Some say 20 to 30. And a few credible voices say it could happen within the next 2 years because quantum hardware has surprised people before.
Virginia, the other thing that makes this complicated, we wouldn't even necessarily see it coming, right? Because quantum breakthroughs could happen in a government lab or a private research facility. And you know, the first public signal that we might see, Bitcoin wallets being drained.
Hold on. And that is the biggest reason why is Bitcoin dead isn't really the right question. The better question is, what happens to Bitcoin if Q-Day arrives before Bitcoin is ready for it?
Well, I can tell you, older wallets with exposed public keys would be the first to target, and then probably a cascade of market panic, then a scramble to coordinate the network-wide upgrade, except Bitcoin has no central authority to just flip a switch.
Now, that's not a death sentence. Bitcoin has survived enormous crises, as we all well know, but it would be the most serious test the network has ever faced.
Yes, and could be the most serious test that it ever has. And here's what's actually being built to prevent it. Post-quantum cryptography is a very serious field. There are blockchain projects that have been working on this for years. One famous example is Norris Protocol. They've won a lot of different awards for their technology, and they're building a decentralized cybersecurity infrastructure designed specifically to be quantum resistant. And they do that by combining post-quantum cryptography with real-time device trust scoring across distributed networks.
And there's QRL, the quantum resistant ledger, one of the first blockchains built specifically to defend against quantum attacks. So instead of traditional Bitcoin-style cryptography, QRL uses quantum resistant hash-based signatures called XMSS. Then there's Cellframe, building quantum-resistant infrastructure to secure cross-chain communication.
You know, Virginia, I have to be honest. That's the part of this that still makes it feel like uncharted territory to me. We're trying to build solutions for a problem that doesn't fully exist yet at scale. And it almost reminds me of the early days of rockets. Right? On paper, the physics worked, everything checked out, but it still took decades of trial and error, explosions, real-world failures, and even deaths before we could reliably send people to space. So the big question is, are we going to be able to properly stress test these systems before quantum computers are powerful enough to attack the current ones?
Yeah, I mean, that's a valid concern, but I would push back just slightly. Unlike rockets, cryptography can be tested mathematically, peer-reviewed globally, and attacked continuously before deployment. Any coders watching out there who have suffered from testnet to mainnet know what I'm talking about. The encouraging part, though, is that post-quantum algorithms aren't being invented blindly. They're based on mathematical problems believed to remain hard even for quantum systems. But the uncomfortable reality is that real-world systems always behave differently at scale. You can prove something is secure in theory, then integrating it into billions of wallets and financial systems introduces entirely new risks. My honest concern isn't whether we invent the algorithms. It's whether society upgrades fast enough and whether decentralized systems can coordinate before quantum capabilities become practical. So let's talk about what this means if you're actually holding Bitcoin right now. Because a lot of people hold it in the same way that they hold gold, as a long-term store of value and inflation hedge, and a bet on digital scarcity.
And Q-Day is actually a big part of why Bitcoin's price isn't higher than it is. And a lot of people aren't talking about this. Institutional investors think about risk much differently than retail. They care more about what they stand to lose versus what they stand to gain. And Q-Day is definitely on their radar.
And here's the thing about gold. You can't hack it. Gold's value doesn't depend on any mathematical assumption. No quantum computer can change what gold is. Bitcoin's scarcity and security are both enforced by math. Math that quantum computing could eventually challenge.
Yes, that said, the quantum threat isn't an argument that Bitcoin goes to zero tomorrow or next week. The timeline, luckily, is long enough that Bitcoin could adapt. Even Michael Saylor, Bitcoin's poster boy, has been vocal about this. His stance is that Bitcoin will transition to cryptography long before quantum computers become powerful enough to threaten the network. That the open source developer ecosystem combined with global cryptographic research will allow Bitcoin to evolve. He's even argued that quantum computing can ultimately strengthen Bitcoin by forcing the network to upgrade. Michael Saylor's eyes, Bitcoin can do no wrong. And according to him, you should leverage your house, sell everything, and just buy Bitcoin.
Interesting thought. Critics argue, and I think that they have a point, that while upgrading cryptography sounds simple in theory, coordinating it across a decentralized global network is a different problem entirely. We've got millions of dormant wallets, older exposed addresses, users who haven't touched their Bitcoin in a decade. You can't just send them a software update.
Right. And this is a big piece that people don't understand. Upgrading Bitcoin isn't just like updating an app on your iPhone. It requires agreement from developers, miners, node operators, and users worldwide. Right? Bitcoin has no CEO. There's no board to vote. So now we have a situation where the system's biggest strength is decentralization becomes its biggest coordination challenge.
The irony. So here's the honest framework for holders. You're not holding an asset that's threatened today. You're holding an asset that needs to successfully navigate a major technical transition within the next decade or two. So the question isn't, is Bitcoin good? The question becomes, do you trust the community to coordinate fast enough?
Here's the thing. Even if you don't hold a single Satoshi, this conversation matters to you because Bitcoin isn't the only thing running on these cryptographic foundations.
Right. Ethereum, the platform that most of DeFi runs on, same exact problem. The smart contracts, the lending protocols, the stable coins, the tokenized real world assets that are increasingly connecting blockchain to traditional finance, literally all of it.
And then beyond crypto, you still have your bank, your email, your government's military communications. Essentially, the entire secure internet is built on the same mathematical assumptions that quantum computing threatens.
So Q-Day isn't just a crypto story. It's actually a civilization level infrastructure story. The reason we're talking about it in the context of Bitcoin is that Bitcoin is probably the most exposed because the blockchain is public, immutable, and has no central authority to push an emergency patch.
That's true, Virginia. And some blockchain networks are actually further ahead on this. There are projects designed from the ground up to be quantum resistant, right? Ethereum's roadmap discusses this and takes it very seriously. Bitcoin, on the other hand, is a slow mover here, which is very ironic given that it's the most valuable.
So the optimistic read is that the urgency of this threat will force the cryptography world to move faster than it normally does. The pessimistic read, we're building more and more of the world's financial infrastructure on a foundation with a known, approaching expiration date, essentially building houses in the sand.
Yeah, you don't want to be building houses on the sand because they will sink quick, pun intended.
Oh.
So Bitcoin isn't broken today. The math still holds, and people are working hard on quantum resistant cryptography that are some of the best people in the world at doing this.
But Q-Day is a real concept with a real timeline, debated, uncertain, but not fictional. And the honest answer to, is Bitcoin safe, is it depends on whether the community moves fast enough.
No lies told there. So guys, if you hold Bitcoin, follow this story, not with panic, but with attention. Because the upgrade question is going to matter more than you think.
And if this is your first time hearing about Q-Day, now you know what to watch for.
We'll link everything in the description. Guys, thank you so much for watching. Till next time on Vinny and Vinny.